Okay, so the goal of this screencast is to learn how to use the polyfit and the polyval functions to find a curve that fits your data. So assume that I went into the lab and I collected these data points. So for my given values of x, I collected given values of y. Now I want to find a curve that goes through all of these values, or most of them. To do that, we can use the polyfit and the polyval functions. But before we do that, we have to make sure that x and y are of the same size. So here, x is of size 1 by 5, and so is y. So they both have 5 elements, so they're of equal size. To use the polyfit function, you have to follow this general format. So on the left hand side, you have the variable name, then you have an equal sign, so it's assigned, then you have the polyfit function. Inside the polyfit function, you have to send it 3 input arguments. So the first input argument should be your independent variable, so in our case it's x. The second argument you send it is your dependent variable, in our case it's y. And then the third parameter, or the argument you send it, should be the order of your polynomial. So you look at your data and you think, okay, well, maybe the function is of order 2, 3, 4, or something else. So you send a number here. And what the MATLAB does is it does calculations and then it returns you the coefficients. So this is what I mean. If you guess that the order of the function is 3, MATLAB is thinking that the function you're referring to has this general format, and that it should return you these 4 values, so the coefficients a, b, c, and d. If you said that the order of your function is 4, MATLAB is thinking that the most general form of the function looks something like this: y is equal to ax to the 4th plus bx cubed plus cx squared plus dx plus e. And it returns you these 5 coefficients: a, b, c, d, and e. So p is assigned a, b, c, d, e in that case. So let's write our line of code. So p is assigned polyfit, and inside the function, the first thing we'll write, again, independent variable, dependent variable, and guess the order. So we'll say 2. To summarize that quickly, MATLAB is thinking y is equal to ax to the 2nd power plus bx plus c, and what it returns is p, which contains the values for a, b, and c. So this is the polyfit part of finding your function, your curve. Now we go to the polyval function. The first thing you do is you define your domain. So you eventually want to graph your function, and I want to graph it from 0 to 10 such that it goes from 0 to 10 and has 101 spaces in between, and it includes 0 and 10. Having done that, you can finally use the polyval function. The polyval function accepts 2 parameters. The first one has to be the coefficients that you got from the polyfit function, so p, and then the second one should be your domain. So in this case, our domain is x1, so we'll put x1 here. And what it returns are corresponding y values for x1 values. So for your x1 values, it gives you y1 values. That's what the polyval function will do. Now to check if the function we just found fits our data points, we can use the plot function and graph both on the same graph and then see if they fit. So x, y, R circle, so RO, and then we'll also want to graph x1, y1, and finally we'll make that a blue line. If you hit save and run the function, you get a graph that looks something like this. So now you see that the points don't really fit that well. They do. This one fits well, but the others not so much. So what your next thought should be is to increase the order of the polynomial. So change the order of the polynomial essentially. I would change it to 3. Let's go by 1. See what happens. And you hit run. And you see that it fits the values much better. Most of the values are completely in the center except for this one. So maybe we can improve it one more time and put a 4. So that gets the order of 4. And again, when you say 4, this changes here. So it becomes this. So it becomes this right here. So MATLAB's thinking that the general function has this look to it. And it gives you back A, B, C, D, and E. So if you hit save, run, alright, we see that almost all the values fit this time and they're at the center. So we can say that this is indeed our function that we're looking for. So if you double click on P in your workspace, the function or the curve has this function, general function. So y is equal to this value times x to the fourth plus this value times x to the third plus this value times x to the second plus this value times x, and then finally plus this constant right here. Now let's look at the general algorithm that you will be following to use polyfit and the polyval functions. So the first thing is you find your x and y points, then you guess the order of a polynomial. Having done that, you can use the polyfit function to find the coefficients in your function, and then you define your domain. Once you have defined your domain, you can use the polyval function to find your y values for your x1 values. Then finally you plot the points, so you plot x, y, x1, and y1, and you see if the points that you initially had the curve goes through all those points. So if they do, you're done. If not, you have to guess a new order and then you repeat this algorithm.